Okay, we'll start again with our last talk of the day with Dean Allemang, who would speak about trust semantics and LLM. In fact, LLM twice, using knowledge graph as accountability.
These slides, I took them from Claude into PowerPoint into Google, and the translation caused problems on many of them. I caught most of them. It would duplicate things, and then when I edited them, it was strange. I would edit them, and it would disappear before my eyes. Like, oh, okay. So I would just type it all back in, and then it was right. Obviously, on the front slide, I failed to do that. So I have the privilege of giving the final talk of the day. And one of the nice things about giving the final talk of the day is that the three speakers ahead of me have done a lot of my work for me. So I don't have to talk a lot about logic. I don't have to talk a lot about RDF. I don't have to talk a lot about OWL, which is a good thing because I didn't intend to go in a deep dive of any of those things, but I refer to all of them. So thank you to all of the speakers that preceded me. The bad part is that you're all tired because you've been listening to all this very well, I want to say difficult, but certainly technical information. And there's been quite a lot of it. I've learned a lot just sitting here. And so I realize that it's the end of the day and you might be a bit tired. I'll ask you to bear with me for my presentation. So I'm talking about trust. How is it that you can trust information out of an LLM or out of a knowledge system? And we're going to build on a whole lot of pillars to get to trust. I want to start by talking a bit about the way ordinary people have turned out to be using AI. So AI has been around for a couple of years now. By AI, I mean the modern generative AI based on LLMs. I did a PhD in artificial intelligence in 1990. The stuff that I did back then bears almost no relationship at all to what we call AI today. Not no relationship, but almost no relationship. The relationships that are there are actually quite fascinating, but that's not the topic of today's talk. So what are some of the things that people are actually doing with AI? We have things like summarizing meeting notes, compose an email where you have some stock thing. We used to have boilerplates, and now we let the LLMs be a little bit more personal. This is one that I do a lot. It used to be you'd get to your terms and conditions of software and it would be pages and pages of stuff. And they would basically be scamming you by knowing that no human being will ever read 23 pages of terms and conditions just to download some software. Well, now I send that off to Claude and go, are there any red flags? And every once in a while there is one, not very often, because guess what? Now they know we can do that. This is an actual way I think the world has improved, that people who write big, long legal documents thinking you won't read them, they can't get away with that anymore. To my mind, this is one of the big things that AI has really, a way it's made my life better. How to use this software. Oh my God, I've learned 3D modeling. I've learned Photoshop. I've learned all sorts of things. I've learned how to use my MacBook. I mean, from the mundane, just ask Claude or GPT or anybody, how do I use this software I've never seen? And you're a small level, expert level in no time. Adjust my resume to a job application. The real point of this slide is what has it turned out people aren't that keen on, and that's this one I've crossed out the bottom, asking a factual question. These things AI's done pretty good at. And people start to learn, no, render into Google what belongs to Google. Google is still the best at actually answering a factual question. Get me a doc somebody wrote about my question and have a person stand behind it. Now in the enterprise, what we're finding at my previous company, Data.World, I've noticed that my bio here still says Data.World. Data.World was bought out by ServiceNow about a year ago, so my byline should say ServiceNow. But one of the things that at both companies we're finding is that enterprises want to ask and get answers to factual questions. What is our gross notional exposure to Acme's debt if Acme defaults? I made that question particularly, come on, speak English, to be very financial jargon laden, because we're going to see how our knowledge graphs can help us with all of that jargon. And then you get an answer. Well, here's some portfolios, and here's the grade of those things, and you have a $74 million exposure. Are you going to base a business decision on that? What's going on here? You have no sources cited. Where did this information come from? The numbers are just asserted. They're not retrieved from anywhere. You can't reconstruct that reasoning. An LLM came up with that answer. You can't, as you come back tomorrow, you get a different answer. We're all familiar with LLMs doing these things. Would you make a business decision in your company based upon that? No, obviously not. The same reason why the people on the previous slide have given up on factual answers. But the enterprise does want this. Here's that picture. You have a question. This is black box of an LLM. Magic happens here. You get an answer. Okay. This is not something an enterprise can use. So what are some things? I'm going to now break this down. What are some specific pillars of trust that we're failing to get from an LLM? One is provenance. Where does the answer come from? So what database, what spreadsheet, what data resource, where did it come from? If you're in banking, I'm using banking for my examples today. In the papers I cite, we use the insurance industry. In some other work I've done, we use healthcare and life sciences. These principles go across all of the domains. I wanted to stick with one domain for this talk, and I chose banking, partly because there's a domain ontology out there that I'm very familiar with called FIBO, the Financial Industry Business Ontology. This is not a talk about FIBO, but I'm going to use it from time to time in this talk. So auditability in banking, an auditor will come and say, okay, you made this decision based on that. How did you come to that? And as for auditors, they're looking for things like inside trading, looking for improper business practices, and so on. Governance. How do you go back and say, I've changed my mind about a policy. I want to now respond to this regulation in a different way. There's been a new court case or something. I want to change how my system behaves. How do you govern it? How do you say this is different from that one? How do you even influence those answers? Training a new LLM is not practical for that kind of thing. And then fidelity. If I ask you a question, how do I know that you're answering the question that I've asked? If I talk to a human being, we've seen this any number of times today. I'm sorry, could you please clarify the question? You do a little back and forth before you answer a question to make sure you're answering the right question. How is that going to work? So these are 4 things that can help with trust. And a plain old LLM pattern just doesn't do these. But I'm going to show you how an LLM working with an ontology and a few other things can actually give you all of these things. So how's that going to work? This is the overall architecture. I'm going to deep dive into every box here, but here's the overall picture. I'm not going to go into any details right now. Your question comes in over the left. We're going to go through a process of disambiguation based very much on what you see in a room like this, where you discuss a question before you answer it. And then instead of having the LLM try to answer a question, it will translate that question into a form where it can be answered in a much more deterministic way. It'll actually write a query for a data system. Now, before we send that query off to our data system, and isn't it nice that the actual data resource is the tiniest thing in this diagram? That, because we're looking at everything else, we're going to validate that query to make sure that it actually makes sense. And one of the speakers this morning, I forget now which one, talked about LLMs generating queries that were syntactically incorrect. That might have been you, or they could also be semantically incorrect. That how do you even know that the query purports to do what you want? And then you send it off to a database and you get your answer back. And we'll talk about how this structure can satisfy all of those non-functional requirements we had on the previous slide. But I'm going to delve into each of these things one by one. Translate is really the paradigm shift here. When we were looking at the LLMs in the first slide, you asked an LLM a question and it gave you an answer from whatever information is inside it, whatever that means. And of course, it means all those encodings and embeddings and all those things. Instead, what we're going to do is to translate your question into a query. So let's have a look at how that goes. So instead of answering the question, it'll take a question. What is our gross notional exposure to Acme's debt if they default? I'm using this little icon as the LLM, and it gives us a query. This query has been copied and pasted from heaven knows where. I actually found some errors in it when I was proofreading the slides, but I'd already sent them in. So don't read that query closely. the query you're supposed to read closely, I'll actually blow up for you. Next question goes in English. A formal query comes out, and we're using the language Sparkle here, which John mentioned that I would tell you more about, and he's right. And this is what LLMs are really good at. They're good at language. It's taking one language and translating it to another language according to some instructions. And you're pattern matching these languages. So we don't have it retrieve a fact. We have it switch into a different language. Let me know when you're finished. I'm going to switch. Okay. Eve has all these slides. I think the intention is to distribute them. So I have put a few references on the slides as well, but the references are also in my abstract if you want to read the papers about them. So if an LLM is working as a translator, what's it going to need? Obviously, it needs the question, but it also needs a description of the data. And then it could take that, and it turns out you can do it as easily as this. Given this description of the data, we'll talk about the different ways you can describe data, and this question in English, write me a query in the following language that does that. And it turns out that they do really, really well at that. But what we'll look at here is how should you describe your data? So for instance, on the first row here, you could do it as a CSV. That's the way that most data on the web is. And it turns out if you go, this was even GPT-3.5. Go to GPT-3.5, you say, I have a spreadsheet with the following column headers. You just give it the column headers. And then you say things like, write me a query in SQL, because after all, there's no standard query language for CSV, at least not that I know of. Write me a query in SQL that will, find which month I had the highest revenue of sales of the products that are cosmetic products, or whatever the spreadsheet's about. You could ask a complicated question like that, and it would write you a query that had the aggregations over the right things, that filtered over the right columns. It would just get it right. You go, damn. Do that again. Get a brand new one. It would get it right. It would just get it right. It would it's like, does it ever get this wrong? Oh my God. Data is completely different now. And actually back, what is it? When did GPT-3.5 come out? That was like 3.5 years ago now, whenever that was. This is what got me really interested in generative AI. Like many people, I'm thinking, okay, there's this thing called GPT. I guess I'll look at it one of these days. Yeah. And a friend of mine on LinkedIn showed it a little experiment, an experiment that anybody could do in 5 minutes, where he took a CSV, started asking questions against it, and GPT-3.5 scored perfectly on it. Okay, this is something that's worth looking at. That's what really got me hooked. Now, the obvious thing to do next is go to an actual relational database where you've got joins. And now how do you describe that? Well, to describe the joins, the way you usually do it is with DDL. DDL isn't exactly a data description language. It's more of a data creation language. It's kind of procedural. But hey, that's the LLMs don't really worry about things like that. And so you can do the same thing. You give it a DDL, and it's going to write real SQL to run against that database. And it turns out that this is great for obviously one table. It's the same as the spreadsheet. 2, 3 tables, it does really, really well. It starts to degrade. And then around 4 or 5 tables, it really got bad. And so everyone I knew who did this experiment, myself included, the person who I on LinkedIn who had turned me on to this, the head of AI at Snowflake, you can imagine Snowflake was very interested in this phenomenon, had tried this, and we all found that wow! And I'm disappointed. Can't really turn that into something that we can market. Well, the executive VP in charge of AI research at Snowflake came to our office one day, and he said, there's this stuff called knowledge graphs and semantic web and semantic layers and ontologies, whatever you want to call that stuff. It seems obvious that would do a better job than DDL at describing data in a way that an LLM could understand. Somebody, looking at me and my colleague Juan Sequeda, somebody ought to set up an experiment and actually test it. What do? Have an ontology that describes the data, have a DDL describe the same data, ask questions against them, have gold standard answers, and do a bake-off. Who scores better? So Juan and I did that, and that's You can see the results of that down here. I think many of you have read this paper. I've heard some of you talk about it already with me so far today. That's describing your data in OWL. Thank you, Uli, for describing OWL for us so much. And query it in Sparkle. Thank you, John, for promising that I'll talk about Sparkle. You're right. And what we found is that now you can get up to way more than 3 classes, sometimes up to dozens of classes that it can actually manage correctly. And the current models are getting better and better at this. And what our study showed is that doing it with OWL and Sparkle scores roughly 3 times better than with DDL and SQL. Now, what do I mean by 3 times better? Read the paper, but it basically comes up to, if you keep score, that the OWL Sparkle ones get the right answer 3 times as often as the DDL ones. The actual breakdown is more detailed than that, but I don't want to go into the details of the experiment. Read the paper, it'll tell you all the measurement details and all the analysis and all that stuff. The real bottom line is that you're 3 times more likely to get a right answer going here than you are here. Then other ways you might do this with LPGs. LPGs are a big deal today. Now, the thing is, there's the way you describe the data in LPG isn't actually standardized, so it's hard to put any word in this column. Cipher is the query language, obviously, that you would generate. And I've known a lot of folks who will sort of do what we did with CSVs, describe their data in a fairly ad hoc way, and then ask the LLMs to produce Cipher, and things work pretty well. What I've not seen is a study done of that, so I can't report any results from that. The folks at NEO actually reproduced, of the 44 questions that we had in our study, we published our data and the methodology and all this sort of stuff, inviting people to use their own favorite formalisms for this. And the Cipher folks did one of them, but they didn't actually publish results, so I don't really know. I would expect Cipher to do much better than DDL. 3 to 1, I'm not sure. I bet it would be not too far off, but yeah, the experiment needs to be done. And what we really did was to invite anybody, because we had a lot of people read our paper and say, oh, there's a logical data formalism that was very popular in the early aughts that did a lot of the same stuff. And of course, Iron says, great. I'd love to know how well that scores. Take our data, take our methodology, we even take our Python framework if you want to, redo the experiment. A friend of mine said, Shackle. How well would Shackle do? And don't ask me, do the experiment. These are experimental questions. And that thing's really important. And I like to stress that because often when I give talks like this, people say, well, how do you know? It's an experimental question. Anyone can reproduce this experiment and collect their own data. And if you don't believe me, then please reproduce my experiment. This is how science works. We're actually doing real science on this slide. Probably I'm going to stop doing real science as soon as this slide moves away, and I'm going to go to industrial engineering. But on this slide, we're actually doing science. If you have questions about this slide, reproduce the experiment and you tell me. I would love to know how Shackle works. I'd love to know how well Cipher works. I'd love to know all the numbers on this side. I'm not going to do all the experiments. Not my job. Hey, there are academics in this room. Often academics come to me and say, Dean, what things could an academic do today that would actually help industry out? There's one example. So I'll give you that answer. So I'm going to focus on the OWL Sparkle way to do this. Now, the next couple slides are absolutely non-scientific. This is complete opinionated guesswork, but I think it's kind of insightful guesswork. The fact of the matter, the measured data says that OWL and Sparkle work 3 times better than DDL and SQL. I'm going to make some conjectured guesses as to why. And the point of doing these guesses here is sort of to massage your intuitions about the differences in these languages. So what you're seeing here, and I think it was Uli who talked about the graphical ways to talk about ontologies as well as the axiomatic ways. I'm doing graphical ones for the purpose of these slides. I absolutely agree with Uli's comment about relying on graphical versions of data or ontologies, and you'll get some misconceptions about what's going on in your data, but they make for great slides. So I am using graphical things for the slides here, although I agree with her 100%. Don't think of this as being what the ontology is. On the left here, I have an ontology, a little tiny one, about the same tiny size as the one that Uli had. And this is talking about, this is actually a small excerpt from FIBO. It talks about portfolios, corporate bonds, legal entities, a thing called a monetary amount. one of the things that FIBO does is to be very careful about what I call things versus strings, what Uli called the difference between the label and the entity. Uli made the same distinction, called it something else. A monetary amount has an actual number, and it has a currency. And so FIBO pulls those things out and then calls it a single thing, which is a monetary amount. There are different kinds of legal entities in FIBO. Now, here's the little excerpt of FIBO to describe things in the banking industry, in this case, corporate bonds and portfolios. Over here, we have data about a particular portfolio and a particular bond and a particular notional amount and a particular legal person and a particular legal entity. The thing to take from this slide is the ontology and the data look a lot alike. They're not exactly alike. I mean, you've got these legal person, legal entity here. You have these two classes here. That is two entities. One of them goes with each one. That doesn't have to be exactly two. They could have been the same. But the shape is the same because the ontology says that portfolios comprise corporate bonds, and Dean's portfolio is going to comprise one or more corporate bonds. And then when you query it, the query looks like the data. So here you have, we want to find a portfolio that comprises a bond that is issued by Acme and has a monetary amount that has some notional value, which we're going to add up. In this case, we're talking about US dollars and held by that legal person. So one of the things that's really nice about OWL, RDF, and Sparkle, and these are words that Uli and John have already introduced you to, is that graphically they look a lot the same. So my first conjecture as to why the LLMs do so well with this is that their input looks like this and their output looks like that. They're not very different. I'm not putting a whole lot of cognitive load, if I dare use that word with an LLM. I mean, I don't want to actually say that LLMs are necessarily cognitive entities, but I'm putting very little attention load, let's say, to use a more technical term, that here to here is just not that hard. Now, check out, think to yourself what a SQL query would look like and how much it looks like the table DDLs. And if you know SQL or DDL, you're probably scratching your head here, and I'll have a slide where I talk about that in a bit more detail. The difference is quite a lot. Now, here's another conjecture that I have. These timelines, I realize I should have aligned the timelines to a single master timeline a bit better, but I didn't think of that until after I sent the slides in. The history of OWL and Sparkle started quite late, 2000, and has moved through, but here's the point. They haven't diverged very much. Now, Uli did talk about different dialects of OWL, and John even mentioned a few of them, but those are in some sense, they're all part of the same line. They were actually developed together and documented together. And we get accused a lot in the semantic web world of saying, oh, I can't use semantic web. It's too academic. Oh, how many academics in the room? Good. I just spat on you in effigy here, like all the people who complain this way are spitting on academics in effigy. But what is one thing that academics of any field must do? There's even a slogan about this. There's one thing every academic must do to be successful in their career: publish or perish. So what are academics doing? They're just sitting around publishing stuff. And who reads those publications? Other academics do. Yes, they do. But who else reads those? Who else reads all that stuff that the academics write? My buddy Claude, our buddy ChatGPT, Gemini, all of our best friends. Claude has read so much about OWL. Even with Uli in the room, I might be able to say, Claude knows more about OWL than anybody here. Uli might be able to gainsay that, but she's the only one that stands a prayer. Claude knows more about OWL than anyone I know. I know, Uli, if you want to gainsay that, we'll get to that in the panel. So we've been writing about OWL, been writing about RDF, and Claude has written it all. And furthermore, whenever they diverge, there's a whole discussion about it, and that committee made a decision. That's the history of OWL and RDF and Sparkle. Contrast to SQL, much older pedigree. However, breaking off as early as 86, again at 92, again at 99. And in fact, Wikipedia is sassy enough to actually say, and despite the existence of standards, virtually no implementations in existence adhere to it fully. I wonder if that Wikipedist had an axe to grind. Yeah?
He says, haha, I am sure Claude has read more than I have.
Thank you, Lily. Good. I was actually worried. I usually say that, but I don't normally have Uli in the audience when I say that. Or Ian is the other one, different Ian, that could gainsay that. So SQL has been splitting apart. And I don't know about you, but every time I use SQL, I always have some issue with the dialect. So one of the reasons why we do so much better might be this, that our academic pedigree is actually working for us, finally. Now, here's the first one that I thought of when we saw this result. And this is a simple example of a many join table in SQL. And it's about Elizabethan writers. And we have a join table here that has indices going off to here and here. Here are some works that were written during the Elizabethan time. I've got Elizabeth herself right here. And here's a bunch of data about that. How do I ask the question in SQL? Who wrote Hamlet? Well, you do something like this. I don't speak SQL. I always let Claude write these for me. You get the person's name from the person P. You join here with wrote. So here's one comparison you need to make. Then you join over here. Here's another comparison you need to make. And then you filter by Hamlet. There's a third comparison. So you're actually writing down 3 comparisons to talk about this question. Who wrote Hamlet? 3 words, 3 comparisons. That seems like an awful lot of work. Now we're going to switch to RDF Sparkle. In RDF, that same data is about as dense. Johnson is a poet. He wrote Volpone. Bacon's a philosopher, wrote Novum Organum. Shakespeare's a playwright, wrote Hamlet, and so on. So thank you, John, for outlining Turtle, which is the language we're writing down RDF. It looks a lot like English. You just sort of have subject, predicate, object going along here. Now, here's the key. Sparkle. Who wrote Hamlet? This is the transcript of this is going to be really tough. The query for who wrote Hamlet is who wrote Hamlet? That's the query. It's exactly the same. There was no work to be done at all. None. One comparison. Bam, right there. We had 3 before, 1 after. Coincidence? I don't know. I said this is the non-scientific part of the talk. All right, but what about hallucinations? How's my time?
20 minutes.
Good. Okay. So we have the LLM doing a translation, and now we're at the we're going to be at this third box here. But what happens if it hallucinates? Every time you think about an LLM, there's this chance of hallucination. Even though we give it this nice question and this description of the data, and even though we're doing 3 times better than SQL, I mean, 3 times 0 is still 3, or still 0. I mean, 3 times 0 is still 3. Yeah, I keep saying that. 3 times 0 is still 0. Maybe you're still at horrible. What if the LLM produces rubbish? And we know that LLMs can produce rubbish. And there was something that Uli talked about today that reminded me of this. My notes are over there. But what we can do, no, it was you, Ian, where you were talking about the validity of things by doing graph search. That's what made me think of this. Remember, this is a reminder from an earlier slide, the ontology looks like this, and the query looks like that. They look a lot alike. So supposing that it does something wrong over here, is there a way we could check it against the ontology? Now, it turns out that back in the days of GPT-4o, it made mistakes on a fairly regular schedule. It made a number of mistakes. And I can actually talk about which mistakes it made. As the models get better and better, mistakes go down lower and lower, and the types of mistakes are changing as well. But this approach works in any case. So here was a common mistake that we saw. We would give it a question. I want to get the notional exposure of bonds issued by Acme. Here's what that looks like. And then it would write this query. partly because this notion of has part, which I think both John and Uli had examples of this in their talk, is a very well-known way to talk about part-whole relationships. And we're talking about a portfolio that has a bond in it. That sounds like a part-whole. Sometimes the LLM will fall back on its background knowledge and put that in instead of what it found in FIBO, which is comprises. Now, here's the fun thing. I'm using this little icon for a deterministic computer. That's not an LLM. That's an actual computer program that just does computing stuff. And what it can do is compare this graph to that graph and do a little graph comparison. And this is where some of the stuff that Ian was talking about. And notice, oh, those two things are different. And it's even in that position, in that situation, in a position to give an English language description. You said has part when you probably meant comprises, and then you could either send that back to an LLM to fix it, or if you're running a little bit more bold, just make the fix and send the query on. But this detection is actually quite easy. You're just comparing graphs that are almost the same anyway. A very common error we saw was this one. It got the right word, comprises, but the arrows go on the wrong way. An example that we were doing in the paper, one of the common ones was agent sells policy. That's how insurance agent works. But the query said, find me all the, it's even hard to say this in English, find me all the policies who have sold an agent. That's obviously gibberish in English. You got the arrow backwards. But once again, you compare and say, wait a minute, that arrow is supposed to go the other way. And you can tell the next round of LLM to do it or just fix it. Here's another way that it might fail. And this doesn't happen nearly as often. Here's a word in FIBO called has notional amount. The question asked for notional amount. It could have accidentally brought another word from FIBO in, has settlement amount. Now, we actually never saw it do this because that's actually pretty weird. If you say, I want has notional amount and it says has settlement amount, why would it ever do that? That's pretty tough to have happen. But it can happen if your original question was kind of ambiguous. It just said, what amount is it? Notional amount or settlement amount? Then the LLM is guessing. It's literally guessing. And it doesn't know what you meant. And that's where this error happens a lot. And you can't really fix this afterwards and say, well, I know you meant this, because you don't know what the original user meant. And that brings us to that first box, the upstream box, of figuring out what the user really meant. Now, I'm going to switch examples from the notional amount to a different one here so I can show up more aspects of this. But humans don't usually ask questions like that one that I showed you before. What is the notional exposure of acme if they, whatever that long, elaborate question was. That's not the way most people ask questions usually. Highly technical people sometimes do, but that's not the way your executive is going to do it. And even highly technical people leave things out. So it's more like, what's our exposure to acme? What does that mean? Which trades settled yesterday? What's the value of our portfolio? And the one I'm going to zoom in on here, what's the best performing bond we issued last quarter? So these are the kinds of questions real people actually ask. So we're at this stage here, the disambiguate stage. We're going to pre-process our questions, as it were, with the cooperation of the user. So what's the best performing bond we issued last quarter? There are three ambiguous things in here. One is best performing. What does that even mean? Another one is we. Who are we? You could imagine that being something that's just set in your session. We is, the agent that the person who's asking the question is affiliated with, or maybe you don't know that. And then what's last quarter? So best performing, we'll look at lots of ways that can happen. Last quarter, lots of ways that can happen. And then do we want to get that from parameterized by the issuer? So that is, we're going to ask that question when we run it. Who do you mean we? Oh, I mean Dean Allemang. That's who I mean we. Okay, fine. How about this? Best performing, is it the highest return, the highest yield, the highest credit rating, the tightest spread over benchmark, or something else? Now, where did it get those choices? Now, this is an actual transcript from, I think it was Claude. Kind of doesn't matter anymore, but I gave Claude a project where I said, your goal is to disambiguate questions. I'm just going to ask you questions, and you just let me know when you've interviewed me enough that you think you can settle on this. And it actually showed me boxes that looked a lot like this. Claude Studio redid them a little bit. But where did it get those things? It took that question, looked through FIBO and said, well, actually, the performance of a portfolio is measured a lot of different ways in FIBO. I'm going to ask you which one you mean. And so FIBO is directing it. It's reading the ontology, looking at my question, and then coming back and interrogating me, the human being, with a highly guided interrogation. And in this case, I said highest price return. And then last quarter, that's another one that's pretty ambiguous. If you have a fiscal year that starts at some time other than January 1st, even if your fiscal year does start at January 1st, by last quarter, do you mean the quarter that just ended a few days ago, or I guess January, February, March, it was a couple months ago now? Or do you actually mean you want to have a quarterly interval, that is today minus 90 days, or something else? And so 90 days prior to today, the fiscal quarter, that's going to ask me for my fiscal year, or the calendar year, because FIBO does not know about my fiscal year, and then whatever issuance dates are in the data set. So it was able to look through FIBO and see how FIBO deals with quarters, and it gave me some selections here. And I just chose the actual first quarter of the calendar year, pretending that I've got a calendar fiscal year. Now that I've answered these three questions, the LM can say, okay, now you've got a question that makes some sense. And now the question does not sound like something a human being would write. Among bonds issued by a specific organization, which we're going to parameterize when we ask the question, which single bond had its first trade date within this date and that date, showed the highest price return, defined as this formula? Ooh, no human being would ever do that. That's especially adding in the formula, but it got that formula out of FIBO. Yeah, 10 minutes, thank you. But that is the sort of question that if you feed it into that second stage and then into that third stage, you don't get those weird hallucinations of saying, well, what do you mean by highest return? No, it's got this word, highest price return is a word from FIBO. It knows how to look that up. And then these dates, those are solid dates it can plug into there. And so now you actually get a real query out of here. And I've said several times that in Sparkle, the query looks like the data, and you can see the query graphically. And so here I'm going to show that this query actually is the one that we got out of running this thing here. You can try to read the fine print, and I welcome you to do so. But you can take a Sparkle query and actually draw it out as a diagram. This is our parameter, the issuer. That's when we're answering whose bond is it. We've got this date that we're going to filter here according to that formula that we saw there. It's this formula. There we go. There's a bond, there's its date, and there's this, in FIBO, there's actually a little two-step way to get to the date. It's kind of like the monetary amount we saw before. I've elided that in this diagram a bit. Ditto with bond, those prices, that is monetary amount that's happening there. There's actually two steps in there. In FIBO, there's also two steps between a bond and the issuer. Why is that? I mean, FIBO works really hard to actually follow business practices. A bond is a loan. A loan is a contract. If you've ever signed a contract for a mortgage or a car loan or something, they always start with the purchaser, Dean Allemang, a natural person residing at blah, 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 agrees to pay the purchase amount and then a number to the seller and then the thing, and the rest of the contract says the seller agrees, the buyer agrees, the purchase amount, the rest of the contract is boilerplate. That's how contracts work. Why do they do that? Legal can validate that boilerplate and say, yeah, if you use that boilerplate, I will stand behind it in court. The little bit at the front is just parameters. It's basically contracts or software engineering. You have a parameter preamble, and then you've got a body that doesn't change. FIBO modeled that. That is the contract, and that is the loan that has all of the all the specified stuff to it. They actually modeled that same thing there. So now this query, now I told you all that cool stuff about FIBO because I'm a FIBO geek, but you know what? You don't need to know that because you know who does know it? Well, the FIBO publication knows it, and Claude can read that. So I'm going to go back to these goals: provenance, auditability, governance, and fidelity. So provenance, so every claim should trace to the actual data set. Every answer is the result of a query. You can actually look back into the database, see where that came from, and you can even see the query. And the query is actually auditable by looking at that structure. You can see what structure the query is looking for. That brings you auditability. The things in the result actually show up in the query. And An auditor can come back and say, okay, what were you looking for in your data when you gave that answer? Governance, this is a fun one. We heard John talk about all sorts of wonderful methodologies for building an ontology. That ontology is now a first-class entity. Somebody can change it. Someone say, I don't like what it did. I'm going to change what it did. Or I've changed my mind about what I want. I'm going to change the ontology to reflect that. It's a first-class entity, as are the mappings of the ontology to the data, which I've sort of been running a bit roughshod over so far in this talk. And then fidelity. Did it really answer the question I want? You can actually go through, you've been taken through an interview process with the LLM. And when you're all done, you can read the expanded question and go, yep, that's what I want to know. Or you can say, oh, no, start again. That was not what I wanted to know. That's not what I meant at all. You actually get to go through that. So all four of these things that an LLM cannot provide for you in and of itself are things that this architecture can provide. So now back to the big picture. We've done the deep dive on everything. Start with a question. We disambiguate it through that interview process. We translate into a query that you can run against a database. We validate that to make sure that it actually matches the way this is going to work. And then we finally run against the database to get an answer. And the whole point here is the role the ontology plays in all of this. The ontology comes in at every stage. At the disambiguation stage, the ontology informs the LLM of what the possibilities are. At the translate stage, the ontology tells the LLM what the structure of the data is so we can write queries. And at the validate, you don't even need an LLM here. You can compare the query to the ontology and make sure that you didn't make any goofy little mistakes. By the time you come to here, you've actually got a pretty good idea that you have got the question that you want and the answer that you want. So why OWL? Why Sparkle? Why an ontology? Can we just be normal here? Why are you doing all this weird stuff? I got tables. I got all my data here. Can't we just do tables? Well, how does an ontology, how does it work better than? Now, is that until the questions start or until I go off stage?
Till the questions start.
Good. Okay. Because I'm almost finished. Yeah. An ontology is queryable. You can actually interrogate the ontology. That's not easy to do with a DDL, and it's no standard way to do it in any case. And it's logical, as I think both Uli and John talked about. Actually, Uli specifically, an ontology can be represented axiomatically. You can prove things about your ontology. Anybody can express nonsense, but when you do it in OWL, you actually know that you're expressing nonsense. And this is the one about the academics. It turns out Claude speaks OWL really, really well. Because the OWL's dialects, there's a handful of them and they are well known. They haven't sort of drifted off over the years. And it knows Sparkle really well. And here's where I've actually said Uli present company included. So, and then similarity, this OWL and Sparkle look alike. So that's something that you don't get out of a DDL or a lot of other representations. It's visual. You can take your query and actually look at it as a picture and you can follow through it. Yeah, you can read the text if you're so inclined, and I am so inclined. But if you're not, you can actually look at your query visually. It's shareable. Now, this is something that we haven't talked a lot about today, but the semantic, actually, I think John may have done. The semantic web languages are actually web languages. They are designed to be shared. Actually, John did talk about this, to be shared across the web. That means I've been using Fibo in all of these examples. I didn't have to use anybody's proprietary ontologies. And John just showed if you don't quite like how Fibo did things, you can map them using his methodology into something else, which is probably the best way to use Fibo anyway. I mean, Fibo's got a lot of work done to it, but it might not match the way you want to use an ontology. Because these are web languages, you can do the stuff that John was doing in Protégé with other ontologies. Or you could take John's ontologies and bring them into yours. Yeah, you have these choices. You aren't working from scratch. Now, I've not at all talked about fair data. I could do an entire lecture on fair data. I'm just going to mention lookup fair data. It's pretty cool. Findable, accessible, interoperable, and reusable. The whole community, especially popular in Europe and especially in the life sciences area, where it's pretty important, and I think Uli talked about this as well, data about this organism does not belong to a single company. Data about this organism belongs to the species, belongs to us. And the companies who use this data to produce drugs, to produce therapies, need to draw upon a huge amount of shared data. How do you go about sharing that data without compromising your business plan? And that's a big part of what fair data is about. And ontologies and RDF are engineered to be findable, accessible, interoperable, and reusable in ways that, thank you, John, talked about quite a lot in his talk. He didn't use the word fair. I was expecting to at some point. And then compatible with other data systems. Graphs are in some sense the mathematically basic way to talk about data. So you can do tables and graphs. You can do document trees and graphs. You can do all sorts of stuff. Control vocabularies, taxonomies as graphs. And so it's nice and compatible with all these other things. Now, I'm going to skip over the next several slides. I was thinking that it could be that somebody would come to my talk saying, I don't even know what a knowledge graph is. I want you to tell me. The slides are here if you want to look them over, but Uli and John and Ian have all done a great job of that. And so because I'm also low on time, these were all optional slides. I'm just going to go to my final references slide. This is my book, Semantic Web for the Working Ontologist. I'm kind of proud that a book that was written in 2008 is still relevant in 2026. I still get people coming up to me saying that this is what really got them into knowledge graphs, and it's still selling very well even to this day. The paper I mentioned about the 3-to-1 improvement is this one here, Dean Allemang and Jacob, Benchmark Understanding the Roles. There's the archive reference here. If you do want to learn about knowledge graphs, there's a course that I built for the EDM Council. They're now called the EDM Association. They merged with a few other associations. Sadly, this course is pre-AI. Pre-Gen AI. So it's all about the semantic web standards, fair data, data sharing, FIBO, data mapping, all this sort of stuff. We're talking about whether we can get enough energy to make a new version of this course to add AI into it. But if you're interested in going a deep dive into knowledge graphs in the semantic web, and then I've got my blog that I write about a lot of these topics right here. And I think I made it. Okay. Question?
QL and OWL, and I would suggest that it does make you better than SQL, as well from my experience as well as always been as a general database structure for whatever computational data you are needed, you were supposed you could use SQL, you could do. And I suppose in the 90s, OWL and Oracle, I did learning this idea of language of structure of more compact. And in this venue, they believe that this server will continue under the same direction. We have shown that
Back to this.
Oh, sorry.
I don't have my slides anymore. Okay. And I don't quite understand the question.
so
So now we're going to play the question thing here.
SQL has been changing in past 90s because features and usable in programmation has been expanding and applying forever. So you have different versions.
Okay, yeah.
Because Oracle is also a shitty company. That's also why. And but OWL has always been on this linear. Always been on this linear version of saying about the same. But since AI and language is also expanding fast now.
Yeah.
Will OWL and RQ also change or maybe modify from their?
Oh, that's a good question. On the one, I don't see them multiplicating the way SQL did because they were standardized early on. SQL was standardized very late and the standard never took. OWL was standardized out of the starting blocks. So I think from that perspective, you're not going to see a big bifurcation. There has been a bifurcation in OWL, and Uli mentioned it sort of in passing. There are like 3 or 4, like we call them profiles of OWL. But the nice thing about the way that W3C did that is they said, okay, these profiles here, they must all use the same vocabulary at the basis, and they're kind of bound together, and they're all being documented together. Now, I don't expect OWL certainly don't expect it to bifurcate in an industrial way because it came from that standard. What I do see is a lot of folks in industry who will just say, oh, OWL is too academic, we're not going to use it. For instance, about half a year ago, actually a handful of companies like Snowflake and Meta and so on announced it was their open semantic layer. I forget exactly what it was called. It was a big thing when it was announced, and then 2 weeks later, I couldn't remember its name. Where they say, we're going to do semantic layer. We're going to make a standard for this that all of us are going to follow. And those of us who have been doing OWL for a long time, well, you can do that, but can you tell us why the one we've already got is not good? So I think that instead of that kind of drift that you get from SQL, where you're going to see is little competitors jumping up, one of them may wind up being very successful. In fact, I could well imagine that all of the motivations behind OWL, which actually I think all three speakers touched on these motivations, things about decidability and things about shareability and so on. All of those motivations were motivations from the pre-AI era. And it could very well be that in our new Gen AI era, we'll find out, you know what? All the reasons we designed OWL the way we did are actually not relevant. We really should do a new one from scratch that is an AI aware, just like the training course that I said I should redo the training course to be AI aware. Maybe we need to make OWL AI aware. I could see that happening. I don't know of any efforts to do that, partly because AI is moving so fast. I have no idea what that means to you. But I could well imagine that in 3 or 4 years, we will know what that means. You might want to say, you know what? OWL 2 was a great thing in its day. We need to do something different. That I could imagine happening, but not until we have a better idea of what AI actually means in this space.
Other question? Yes, I would have a question is that I think your general methodology is also quite interesting. It's kind of stuff that you're facing constantly and computer science, like when you're trying to configure something, you're faced with what can I write? What are the exact terms and how can I write that up?
Mm-hmm.
So in your case, what's interesting in methodology is that having the ontology, say if you see some word like account, then you can look up in the ontology and say, oh, in the ontology, I don't have account, but I have banking account and I have maybe membership account. I have this other thing. So what do you mean? So you're able to some sort of push the user into the direction of what of the kind of terms and the concepts on the role that he's allowed to use because these are the ones that exist. But also with the other step that so you have this generation of some sort of query. So at least it gives you an example of a query so you can see once how this is formalized. And then when you're executing it, you can see what come back, and then you can see the garbage coming out, and so that you'll have to do. And I think you have this general setting that you have that, and when you're trying to configure some software, so you have some software, and then you can configure it by writing things into a file. But then what are the name of the things that you can write in the file? Do you have to put space in the front of the equal sign or not? So you can look in the documentation, but at some point you get confused about the term that you're allowed to use. But you also have the other level too, is that when you're writing down something, then what are the allowable values that you can give to this thing? And then finally, there's also some sort of more meta level thing like you have like in the return of the query, is that maybe all the individual lines that you're writing are correct, but altogether doesn't make sense. So do you think you have like some sort of general methodology that you could also use with configuration files, and if you could get this information, you could do the loop like that to some sort of...
So what I can speak to that is a discovery that my team at ServiceNow made about a month ago. What's the date today? little bit over a month ago. And I was, well, on the one hand, delighted, and the other hand, disappointed to find when I went to the Knowledge Graph conference in New York about a month ago, that this same discovery had been made by no less than 4 of the companies that were presenting there. And I would say, you've almost described it here. And here's the situation. If someone's coming in saying, what I want to do is build an enterprise ontology that will somehow bring together and summarize all the data sets I have in my enterprise, then what you can do with this methodology that goes all the way back to the 90s or even 80s that they call competency questions, say, what are the questions that at the enterprise I'd like to answer? And you start with that. And I've actually been very critical of competency question methodology, and I'm going to have to turn around on that criticism because of the story I'm about to tell. Now, if you say, Claude, I want you to write in OWL an ontology that matches if my business needs the data, where do those business needs come from? Yet to come. And from that ontology, look at the data schema and write a mapping in R2RML, which is the semantic web language for doing mappings from ontologies to data. And then write your queries exactly what we were just saying. Can I write a query on that ontology to answer my question? If I can that map to the actual data resources? If it can I actually run that query and get answers? And if I can, do those answers actually make sense? Okay, you can actually do all of those things with multiple data sources. Now, where does your business logic come from? Turns out pretty much every company I've worked for has like an enterprise architecture group who has been trying to write out general principles for how we manage data here at ServiceNow, at Data.World, at Bank of America, at wherever. Or they have demos that they give to their customers that they're selling to that say, here is a business need we've seen you have, and here is how our product solves it, and you give a script. Turns out you take those business documents, give them to Claude, and take those questions and give them to Claude and say, write me an ontology. It will do a darn good job of it, but only darn good, not wonderful. Then you say, here's my actual data sets. Data catalog, remember Data.World was a data catalog company. Scrape the shapes of those data resources. And that could also be Power BI or Databricks, so things that aren't databases alone. Scrape that stuff off. Do your best to map. If you can't map anything, go back to the catalog and see if there's more metadata. And here's what Claude is really stupidly good at. Questions, business docs, data schema, database. That whole stack in between. Claude, debug this into existence. I'll be back in the morning. Come back the next morning and says, okay, 255 of your questions are now being answered correctly. I've built an ontology of all these things. I've done all the mappings, and it all passes all 250 of your competency question tests. That took me to 22 minutes. Okay. What do you think? Okay, and the reason it works is the feedback loop, exactly what you were saying. Now, I'm doing it entirely with the ontology stack. You're talking about doing it with more general configuration settings, and I think you might be onto something. I haven't played that experiment. I've done it entirely within the semantic technology stack. But yeah, the story I just told makes you think this would probably work for just about anything.
That's watching online. I put it on the screen. Do you want to read it? It's kind of small. I can.
I'll read it out loud.
Okay.
I think this is really interesting and promising. So not trying to poke holes at all, but wondering about the continued impact of plausible text generation as the base objective function. Yeah. I mean, it works fabulously well for lots of things, obviously, but it does intertwine language, frequency, and truth. I'm wondering if even once you have a well-framed and precise question, if it is bizarre, then does the model struggle? The substrate of this question is that the plausible text generation and alignment can be in varying ways homogenizing. So sometimes well-trodden paths look good, but the weird stuff, esoteric exegesis, how do you say that word? Gets you back into an odd failure mode. Do you think providing ontological scaffolding can ameliorate this issue partly or entirely? I'm going to go on a limb and say entirely. And the reason I'm going to say that is that interview process. Let's suppose that a human being comes in with what was the word you used? Let's see, a bizarre question. that doesn't make any sense. One of the nice things about having your ontology written out in front of you, you actually know what you can't answer. So if you come in here and you say, my bond exposure, how much is that in armadillo skins? We don't have any conversions to armadillo skins. Did you mean something else? And the struggle won't happen downstream. It's going to happen during that interview process while that user's still there on the hook. And if you can't get the user to actually say something coherent, if the user insists on something bizarre, that interview process is never going to congeal. And if that interview process never congeals, then you really have nothing to send downstream. But the user is still on the hook. It's not like, okay, I'm just go ahead and do whatever the F I want. No, it's going to be, sorry, you have not given me enough information to disambiguate this. I really honestly don't know what you're talking about. So I would actually say that this structure, in some sense, aims right at this issue. That and you can even imagine a hostile user coming in. You know, a hostile user comes in, and I'm going to sit here and F with this stupid AI's brain, and they're going to sit here and just tell you inconsistent answers. Yeah, that poor first step is never going to coalesce. And that means what you're never going to do is get to an answer saying, okay, fine, will you shut up now? No, it's not going to do that. It's not going to even get past that first step. So I think that actually this structure helps out with this a lot. Oh, thank you. Oh, how's our timing?
It's left for the
Okay.
questions. One last question.
Okay, if there's any more questions?
But in relationship with that, in some sort of way, in your case, you're using text generation, but you could have machine learning just to produce directly formal like Sparkle expression instead of.
Yeah, actually, there was one of the talks at KGC where somebody did that. And at first I was kind of bewildered by it because I thought, well, you got an LLM here. Why don't you just use it? LLMs are expensive. And in fact, it took me a while to get my head around that with this talk that I saw. But the folks at KGC, in some sense, are way ahead of me here. They've been doing this for a year. ServiceNow is a fairly slow-moving company, I'm afraid. And so we have not moved our research forward as fast as we'd like. And there was one talk there where they were saying, you know what, we can actually use vector databases or machine learning systems to do an awful lot of this stuff. And so they were generating queries. I don't know, just ask Claude to write your queries. And yeah, and I could use my, however many tokens doing that, or I can do it with, they were doing vector databases and finely tuned vector databases and something else. I forget how they were doing it to do exactly that. And what they were really interested in is how can I economize on my LLM tokens? So I don't know how to do this, but I saw a talk by somebody who does.
Okay, there's no other questions. Thank you very much.